Now let's look at another problem, which is find the square root of a number. So basically what will happen as part of this problem is that you will be given a positive integer number and return the square root of the number rounded to the nearest integer. You are not allowed to use any built-in libraries and you have to implement the logic all by yourself. So that is the problem statement. So here let's just try to understand what we can do, after looking at some of the examples. So here the number that we have gotten is 9, right? 9 is nothing but 3 square, so the square root is nothing but 3. And here we have gotten the number 8. The square root of 8 is not a whole integer, rather it is something like 2.8248, something like this. So here if we round it down to nearest integer, it will be 2, right? That is the reason why here we need to return 2. Obviously here if we got 4, it is nothing but 2 square, right? So the square root is nothing but 2, so we have returned 2. And here obviously we've gotten 0. 0 square root is nothing but 0 itself. Remember here as part of the problem statement we've gotten that we will only be given the positive integers. If at all if you get negative integers will not have a square root, right? So obviously you can put a simple check before writing the main business logic and you can exclude all negative integers, and based on your interviewer's choice you can either return -1 or 0 or indicate basically to represent that situation. So that is completely up to you. Now let's look into what are the different ways in which we can solve this problem. So first let's try to understand the brute force approach. So brute force approach is nothing but naive approach, right? So here let's just assume that the number that we have gotten is 9, and after that we will try to understand for another integer 8. Okay, now immediately what we can do is we can simply start the iteration logic, and we can start the iteration from 0 till the given number itself. Okay, so in the worst case the square root can go till its number itself, right? Which is not true. We will be able to find till basically by the time we reach half the number that we've gotten, we will be able to find the square root. But here we will be writing the logic till number, and immediately what we will do, if the number multiplied by number is equal to the given I into I multiplied by itself is equal to the number, then we found the square root, which is nothing but I itself. So here we can return I here itself. If this is not the case, the other scenario is I multiplied by I is greater than the number. That means once the number is multiplied by itself, it has become greater than that. That means that the number did not have a valid whole square root integer. This is where we need to return the proper value. So in this case we will return I minus 1 because we need to round it down to the nearest integer. And if this is not the case, we still not have met any of these conditions, we should simply move on to the next integer as part of the iteration. So this is the simple iterative brute force approach for finding the square root. Now let's see for the example 9, right? So we will start from 0. I into I multiplied by itself is 0. 0 is less than 9. So it did not match this condition and it did not match this condition. So immediately I will become 1. Now 1 multiplied by 1 is nothing but 1, and the value we have is 9. So it did not match any of these conditions. So immediately we will move to next value. 2 into 2 is 4 is less than 9, and still we have not matched. So immediately we will move on to 3. So 3 square is 9. 9 is equal to 9. So we have a perfect square root, which is nothing but 3. So we will return 3 from here. Okay, so that is the logic in the case of 9. Now let's look at the square root for 8. So here we will start from index 0. 0 into 0 is 0 itself, and the value we want is 8, right? So 0 less than 8, so none of these conditions are matched. So immediately we will move on to the next value. 1 multiplied by 1 is which is less than 8 itself, so none of these conditions match. So we will move on to the next value. 2 square is 4. 4 is less than 8, so none of these conditions match. So immediately we will move on to the next number. Next we will get 3. 3 square is 9. 9 is greater than 8. So in this case, we will match this condition. So here what we will do, we will return I minus 1. I was 3, right? So 3 minus 1, 2 is what we will be returning, because we need to return the closest square root whole integer. So 2 square root is nothing but 2.82, something like that we discussed, right, while looking at the problem description. So here we need to return 2. So 3 minus 1 is nothing but 2, and 2 is what we will be returning. Okay, similarly you can look at any number. Ultimately the brute force approach that we have written will return the proper square root for all the scenarios based on the problem description, and this is what the brute force approach is. Okay, now here is where we can think of bringing down the number of iterations that we have to do for finding the square root. That is where the binary searching technique comes into the picture. Okay, so I will clear out the screen and I'll try to explain how can we approach this problem from the binary search perspective. Now let's try to understand how can we find the square root of a number using the binary searching technique. Here also let's just assume that the number that we have gotten is 9 in the beginning. So immediately what we will do is the square root will be anywhere from 0 till 9, right? So all the values we have from 0 to 9 are nothing but 0, 1, 2, 3, 4 till 9. Basically 9 I am taking because till the number that we have gotten. If you see, all these values are sorted in the ascending order, right? That means that we can apply binary searching technique in that range. So what we will do is we will initialize the start with 0 and end with the given number itself. Immediately what we will do, we will calculate the middle. Middle is nothing but 9 by 0 plus 9 divided by 2, which is nothing but 4.5. So if we round it down, we will get 4. Now what we will do is we will multiply by itself. 4 square is, we've gotten middle of 4 somewhere in the middle. Now 4 square is 16, right? But the target we are looking for is 9. That means the square root will be anywhere on the start till middle minus 1. So that is an important thing, because if we multiply 4 by itself, we are getting 16, but the number we are looking, the square root we are looking for is 9. So it should be somewhere less than 4, right? That is the reason why immediately what we will do is start will be 0 right now and end will be middle minus 1. So it will be 3. So 0 to 3 will become our search range. So immediately what we will do, we will again calculate the middle. 0 plus 3 by 2, which is nothing but 1.5. So if we floor it, we will get 1. Now what we will do, we got a middle. So 1 into 1, which is nothing but 1 itself. But the number that we are looking for is, square root is 9. So 1 is smaller than 9, right? So what will happen? It should be somewhere on the right of middle. So middle is at 1 right now. So immediately what we will do, it should be somewhere on the right part. That is the reason why now start what we will do is we will increment it by, we will update it by middle plus 1. So start will be middle plus 1, which is nothing but 1 plus 1, 2, and end will be whatever we have, which is 3. So this will become our search range. So immediately what will happen, we will again calculate middle. 2 plus 3 by 2, which is nothing but 5 by 2, 2.5. If we bring it down, it will be 2. So we have gotten the middle to 2 itself. Now 2 square is 4, but the number that we are looking for is 9. That means 4 is smaller than 9. So what we should do, we should look somewhere on the right. So what we do, immediately we will update the start to middle plus 1, which is nothing but 3 itself. Now again we will calculate the middle, which is nothing but 3 plus 3 by 2, which is nothing but 3. Now the middle is nothing but 3. So if we square it, 3 square is nothing but 9. So the square root that we want is also 9 itself. So we've gotten 3, which is giving 9. So immediately we can return this middle itself. So that is the logic. But what if the number is 8, let's assume, right? In that case, what we will do is we will write the same logic But once we check all the iterations, like whatever the start is less than or equal to end loop that we will run in a binary searching technique, we will check all the scenarios. If at all we did not find any whole integer which is giving us the given target, then what we do is after checking all that, in the end, whatever the start we have, right, this start will be pointing to the next whole integer. So what we do is we will subtract by 1 and we will return that. So that is what we will be doing. So for that, let me just explain one example, right? So here let's just assume that n we have gotten is 10. 10 does not have a valid square root, right? So what we will do, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 is what we will be taking. So let's try to apply the binary searching technique. So start is at 0, end is at 10. So middle is nothing but 10 plus 0 by 2, which is nothing but 5. So at 5 we've got in the middle. 5 square is 25, but we want 10 only. 25 is greater than 10. So what we should do, we should look in the left part. So this will become our search range 0 to 4, because we update the end with middle minus 1. So end is here, start is here. Now again we will calculate the middle. 0 plus 4 divided by 2, which is nothing but 2 itself. So we have gotten the middle at 2. 2 square is 4, but we want 10. 10 is greater than 4, right? So what we should do, we should look somewhere in this range. So start is at 3, end is at 4. Again we will calculate the middle. 3 plus 4 by 2, which is nothing but 7 by 2, 3.5, and it will be 3. So 3 square is 9. 9, but we want 10. That means we should look on the right. So what we will do, we will update the, start with middle plus 1, which is nothing but 3 plus 1. So start also will be at the same position. Now 4 plus 4 divided by 2, which is nothing but 4 itself. 4 square is 16, but we want 10 only. That means it should look on the left. Now end we will update with middle minus 1. So end will be pointing to 3. Now we can no longer run the loop, right? Because start is greater than end. So we can no longer run the iteration, and the start is pointing to the value 4. Now 10's square root is nothing but 3. But here the start is pointing to 4, right? That means whatever the start that we have, minus 1, we will need to return in the end to return the nearest square root of that particular value. If at all we had gotten 16 or something like that, then we would have matched 16 at this 4 based on either going to left or right. We would have matched it 4 and we would have returned 4 itself. Since the 10 does not have a valid perfect square root, this is what we need to do after checking all the ranges. Okay, so that is the implementation. Now let's just quickly dive into the pseudo code for this algorithm that we have discussed. So what we will do, we will write one function called find square root, and it will take the number. What we will do, we will initialize start with 0, end with number itself. Along with that, what we will do, we will initialize middle with minus 1. Now simply run a loop as long as start is less than or equal to end. What we will do, we will calculate the middle. Middle is nothing but start plus end divided by 2. Immediately what we will do, we will perform the square, which is nothing but middle multiplied by middle is equal to the given number. This middle itself is perfect square root, and we can return that middle value itself. If this is not the case, then this multiplied result can be greater or lesser, right? If this is greater, that means middle into middle is greater than the number, then what we should do, we should look on the left part of the array, because left parts yield the smaller or equal values. So in that case, end we will update with middle minus 1. Otherwise it is smaller, we should look for the greater value. That is the reason why we will update the start with middle plus 1. Okay, now as part of this while loop, if at all if the number has a valid perfect square root, we will return it here. Otherwise if the number does not have a valid perfect square root, like I mentioned while explaining a sample while dry running the code, what we should do, start will be pointing to 1 greater than what it should be returning. So it will return, we should return start minus 1 in the end after completing all the range checks in the while loop. Okay, so this is the binary search based logic for finding the square root of a number, and the time complexity of this will be order of log n and the space complexity will be order of 1. Basically it is not order of log n because we are applying the binary searching technique. We can say it is order of log n, but ultimately the number of iterations will be lesser than what we have taken in the brute force approach for finding the square root of a number. Okay, so that is it for this one. Now that we understood the logic and everything, let's quickly jump in and write the code and validate various scenarios.